Did you know that you spend 90% of your time indoors? You might think that I'm exaggerating. It can't be quite that high. But when you think about it, it makes sense. And this is the figure used in North America. We spend a lot of time in our day sleeping. We spend an awful lot of time in our day working. And then we go home to rest. And it accounts for 90% of our life. This is why it's critically important that we clean the air inside of our buildings. We need to clean the air to prevent particle buildup that we generate indoors. And we also need to prevent particles from entering from the outdoors. To do this, most buildings use fibrous air filters. These filters are highly effective at removing particles. Fortunately, they also have a high resistance to the flow in the system. This resistance translates to a high energy cost. The focus of my research is to provide an understanding of this energy use for air filters, and to hopefully improve the energy efficiency for operation in all of our buildings. To do this, I first look at a macro-scale model of filter energy use. And what this is an analytical method to calculate just how much energy does it cost us to run the filtration systems in our buildings. And what this allows me to do is to compare different filters from different manufacturers installed in any system, anywhere in the world, and to determine which is the most energy efficient at removing particles. It also allows me to look at different ways of controlling and operating our air handling systems to improve upon the energy efficiency and indoor air quality inside buildings. And finally, it allows us to produce a standard for comparing filter energy efficiency, a standard which, surprisingly enough, doesn't exist anywhere in the world. This is filtering on a macro scale, and since what I look at is micro and nanoparticles, I have to also look at the filter from the micro scale. And to do this, I investigate filter properties, such as the fiber size, the packing density, and the general layout, to understand how this affects the energy use. I also take a look at the particles that build up themselves, since this is what we're actually filtering. And we notice that as a filter operates, and you accumulate particles, the energy cost starts to increase. And we want to understand how we can manage this energy cost. One method of doing this is to introduce nanofibers inside a filter matrix to increase the filtration efficiency and reduce the cost of operating our filters. All of this is performed to improve the energy efficiency of our air filter systems for people who never seem to find enough time to get outdoors. Thank you.